Hey everyone, welcome back to MLWorks. In this video, we'll continue our discussion on reinforcement learning. And in the first part of the reinforcement learning, we discussed what is reinforcement learning with an example of a kid playing a video game. And then we discussed what is reinforcement learning process, which is state, action, rewards, and then new state. Okay, so that's the whole process of RL. And then we discussed about observation and state space, and then we talked about action space. And then we discussed rewards and discounting in RL. Now in this section, what we'll do is we'll talk about different types of RL task, and then we'll discuss exploration and exploitation in RL, and then two key approaches for solving RL problems. So let's talk about different types of RL task first of all. So there are like episodic task and there is continuing task. So what I mean by episodic task, right? So when a task has a start and end point, the task is an episodic task. And when you have such a task, there is some list of actions, states, and rewards that is possible. Okay. And for instance, okay, think about the game Super Mario, where you have a start of the game where the Mario jumps and collects coins and everything, and he reaches the end point or he gets killed. Okay, there is start and end point to the whole task. Okay, so when it comes to continuing task, there is no termination state. Okay, so the task continues forever, and the agent must learn from the continuous state changes and take action based on it. Okay, so that is something called as, for instance, right? Example is like stock trading. Okay. It keeps running. Okay, the stock never stops. Okay, the whole thing keeps running, the stock market. Okay, and then it gets only interrupted. The agent only stops only when the user wants to stop it. Okay, so that is the example for continuing task. Now, when it comes to exploration and exploitation in RL, exploration is nothing but you have an environment given to you for an agent. Okay. So you take random actions in order to find or explore more information about the environment. While you're doing that, you get the rewards. Okay. And when it comes to exploitation, so you have consider given an environment and you know certain states or certain conditions, right, around your agent, right, around the agent. You just try to utilize that information. You don't explore, you just exploit the given information and get the rewards or maximize the rewards. Okay. So these two states, okay, exploration and exploitation are the two kind of states, right, where you either stay in the same place and get the rewards, or you explore more environment and then get the better rewards. Okay, so you have to understand when you have to explore and when you have to exploit. Okay, that is one of the key trade-off that has to be understood in RL. Okay, so we'll talk about that next. So the exploration and exploitation trade-off, what I mean by that, okay. So consider you have a maze and you have a mouse. Okay, mouse is able to get infinite amount of small cheese in the given specified environment which it knows already. Okay, but there are other rewards or cheese that is available in a different state or in different environment it has to go through. Okay, so for that it has to either first it has to exploit. Okay, if it is only exploiting, it is only capable of getting all the rewards which are nearby it. Okay, and it will miss out on the major chunk or gigantic reward which is available if it is able to do little bit of exploration. Okay, for instance, if you see here, this mouse has an infinite amount of small cheeses. Okay, if it is not exploring anything, it will keep getting these rewards, nearby rewards. But if it tends to move ahead and walk a little bit, right, or traverse through this maze, it can able to get this reward also. It has to explore for that, and while it is doing it, while sitting here and doing it, it is called exploitation. So there are like rules in RL that has to be created such that the mouse is able to identify places or the states where it can maximize the rewards. Now let's talk about the two main approaches for solving the RL problems. So the key part of machine learning is you have a machine learning model and that model learns an objective function. So when it comes to RL problem, there is something called as a policy, which is nothing but a function that learns which action to take for a given state. Okay, so we find the optimal policy such that we have the maximum rewards. Okay, so that's the key idea behind policy for RL problems. Okay, so now the problem statement turns towards how to find an optimal policy or train an optimal policy for a RL problem. Now there are two key approaches for training or finding an optimal policy. One is called policy based method, the other is value based method. So policy based method is nothing but for a given state the agent learns what action to take. Okay, for a given state what action to take. Okay, and which is direct actually. Okay, and when it comes to value based method, okay, you have a given state, what is the reward you will get, that is what, how valuable that state is, and then action is taken. Okay, so that is what only one main difference is there. Okay, you have value given to a state in value based method, and in policy based method we directly say, okay, take this action for a given state. Okay, that's the key difference between policy and value based method. Now policy based method, as I said, it is learning a function directly. Okay, there could be two things, right? For a given state, okay, you already tell, okay, what you call specific action needs to be taken. That is like for each state, what is the corresponding action? That is deterministic. You already tell the agent what action needs to be taken for a given state. But when it comes to stochastic based policy function, okay, what will happen is for a given state, okay, or for a given state, you will generate an action, a probability distribution for a set of actions. Okay, so what will happen is the action with the highest probability will be taken up. Okay, it's not like you have one-to-one mapping, you will have one to a probability distribution. For a given state, you will have a probability distribution for the actions. The action which has the highest probability, you will take that action. That is stochastic based policy method. Now let's understand this here. So if you see in this particular robot, like a maze kind of thing, you can see here, you will see under each state, okay, there is a direction is given. Okay, what action needs to be taken. It is saying that you have to go right. In this state, it is saying go right. And if you are in this state, it is saying you have to go up. If you are in this state, you have to go up. Okay, so we have actions that needs to be taken for a given state. That is the whole point. Okay, and it is determined by the state and action mentioned here. And if you want to look at this specific example where you have a game where whatever the character is trying to move. Okay, so it is going through a policy function and it will keep, if you are pressing one button, it will keep moving in certain direction. Okay, that is deterministic approach. And a policy at any given state will always return the same action. So if you keep pressing the same button, it will keep moving forward. Okay, so that's the deterministic approach. But when it comes to stochastic, okay, so if you press something, okay, you will create a probability distribution. Okay, whether you have to go up or you have to go down or you have to go back or something, right? So you have a probability distribution for that, and you will get, for example, here if you can see, the button left has 0.1 probability, the right button has 0.7 probability, and jump button has 0.2 probability. Okay, this is stochastic way of providing the action that needs to be taken for a given environment or a state. Okay, the outputs are probability distribution over the actions. So this is quite simple. Okay, you have one-to-one mapping here, you have probability distribution mapping. So when it comes to value-based method, okay, as I said, there is a value for every action that is taken for a given state. Okay, so it maps the state to the expected value from being in that state, from being in the state. If you are in state, what will be the value that you will be getting? Okay, if you are in that state. Okay, for a better way of what understanding is this particular maze again. Okay, so if you see here, in this block, if you are present, you will get -7 points. And then if you move to this one, so it is getting reduced, right? If you are moving to this direction, it is reduced. So you will be moving this direction. Now, but if you see, if you move this direction, it will be -5. And if you move down again, it will be increasing. The rewards will be decreasing here because -7 is like affect the policy like in a bad way. Okay. So what you will do is you will tend to move to this direction, -4, and then you will move towards -4, then -3, -2. Because these are like positive rewards that you are getting, or negative rewards that is getting reduced. Okay, and finally you will reach your goal. Okay, so as I said, thanks to the value function right here, At each step, the policy will select the biggest value defined by the value function, -7, then -6 and -5 and so on to attain the goal. Okay. According to the policy, act according to the policy just means the policy is going to the state with the highest value. So according to all these set of values that is present, we have to switch towards values which will keep reducing. Okay, in terms of if it is negative, it has to reduce. Okay, if it is positive, it has to increase. So this is what value based method is, where you have for each state a value is present already and you have to take the action based on that value. So with that, I just want to talk about the specific resource, right, which is provided by Hugging Face. This is the course material, okay, which will be containing all the things that I have explained. Okay, it is the pure in-depth deep RL course that you have to take. It is very good to understand how deep reinforcement learning works. Okay, so with that, I'll conclude this video. Thanks for watching.